So if you've seen Java programs or C++ programs, comments will make sense, complete sense to you. Comments start with a slash star, any amount of text or no text, and end with a star slash. If you use the slash star kind of comment, you can span as many lines as you need and then end it with a star slash. The slash slash comment style of comments is used if you want to have a comment that just spans just this one line. Everything from the slash double slash to the end of the line is considered a comment, and the next line is considered not a comment unless you have another slash double slash. Although it says this comment is not portable, we will use it a lot. What it means is that there might be some C compilers that that will not accept this double slash. So yeah, there it can happen, but for almost everything that we will do, this will work. So no problems with that. Main is a special function that the system uses as a starting point for running a program, and so every program that you want to run has to have a main. Even though you can call main from other functions, you probably shouldn't. So you can actually call main from another function, but yeah, unless you know what you're doing, you probably shouldn't do that. And you can try it, certainly try it. So like any other function, main can return a value and take input arguments, but these are sort of constrained. So there are some constraints to using main. Main has to return an int. If you try to return a double, there you might run into some problems. It might sort of work. In addition, this is the most important thing. Main takes either no arguments or 2. So either no arguments, that is empty, or 2. And those 2 arguments, if you do have them, they have to be an int and an array of null terminated strings. So that int is the number of arguments in this array. So if you're used to Java, you might recall that all your public static void main methods take one argument, which is an array of strings. And remember, in Java, every array has a public static final called public final called length, which contains the number of elements in that array. And so because arrays already contain the number of elements in that array, we didn't need this first argument that we have in C. So in C, we have to explicitly say how many things there are in this array. It's not built into C arrays. So we'll get into more details of how arrays work in C, but for now, you might want to just note that difference between Java main methods and the main function, the arguments in the main function in a C or C++ program. So main will, once again, will take no arguments, that is 0 arguments in main, or 2, an int and an array. And that array has to be null terminated strings. If you're not familiar with null terminated strings, if you've never seen this phrase before, we will see this a lot, much later on in this course. So you can think of the int as being the $$ in bash scripts, and the null terminated strings as the $1, $2, and so on. Those arguments to the script. Okay, so you can actually set up a main that is void, that is, it doesn't return anything. This might when you try to compile this, might generate a warning on some systems. On some systems, this will work just fine. So if you had a void method, a void function for main, if main were a void function, then you don't have to return anything. And so that is part of the problem, is that most programs expect your program to return something, and that's treated as either 0 means it worked, anything other than 0 typically means it did not work, and so that is can be a problem if you on a lot of systems. Not all systems. Some systems will allow you to have main be a void function. Okay, so here's the simplest C program that quote unquote works. And you can actually omit the return. I believe that, well, you might want to try it. If you omit this return, you might get a warning. So this would be a simplest program that actually creates no warnings, creates an executable file on just about any hardware and using any compiler. This should work, always work. If this doesn't work, well, there's some non-standard behavior in your compiler probably. Okay, program termination. How do you end a program? You can either return, and typically you want to return a number, or you can use the exit function to end a program. Exit is what stops a program. A return from main causes the exit to be called. So if you use return, you're actually using exit indirectly. You can use exit anywhere in your program. So you can, for example, put exit right at the beginning and then none of your code will work. So that's, you can do that, but probably don't want to. And so if you have detect an error condition, you can call the exit function to stop the program completely before it does some damage or something like that. So you can also return from within main. But you can also, in addition, if you're in a function that's called by main, you can, in that function, you can call exit and stop the program from within some other function other than main. So there are some slight differences. Most of the time we will use return. Okay, so here are some possibilities. You can say this is what you should have. This is the bare minimum. You have to have main return an int, and therefore it should have a return statement with a valid int. Remember that whatever you return has to match the return type of whatever function you declared. So you can also say return semicolon. Most systems will take, most compilers will take this. Some of them might generate a warning. You could also try this. You could say int main and then not have a return statement. Sometimes some compilers will give you a warning, but it'll work. You should be able to create an executable and then run it. And in addition, you can also, instead of the return, type in exit. But here you do need the open paren, close paren, and some int. So exit, the reason you need the open close paren is because exit is a function that takes one single argument in most systems. Okay, so exit returns an exit status, which indicates the state of the program as it stops, and 0 means the program ended successfully. Anything from 1 to 255. So you can actually use negative numbers, but those are translated to a single byte, and that's the standard. So you can say -1, but that'll be translated to, I think it'll be translated to 255, and so that indicates a failure. So that's why exit was used in such a way that what it returns is a single byte, and so at that point bytes are not signed, that is, there's no sign to it, and that's why it would take negative numbers or positive numbers and treat them as failure. And we will get into more details of this, like what is a positive number, what's a negative number, especially in the context of a single byte. So where is this used? Where is this return code used? It's used in, for example, a shell script. And remember, with the ampersand, if you want to execute two things based on whether the first one worked or not, this is the kind of code that's checked. So the status of the program can be tested in a shell script, and then you can either use ampersand or the double straight line operator, that's the OR function. So we use that in shell scripts, and so that's where we will test the status of a program. Okay, So the nice thing is that as with C++ and Java, the compiler ignores indentation. So this is not true if you're doing things like if you're using, for example, Python. In a Python program, the indentation means something, and that's not the case in C++ and Java. So if you're coming from C++ and Java, it's the same rule as C++ and Java. New lines, tabs, spaces are all considered white space and are equivalent. They are pretty much equivalent. So you can have all of your code on one line. Not something you want to do in a language like Python, because there the indentation is part of the syntax. In C++, Java, and in C, we use indentation and tabs to make the program readable. In Python, indentation and tabs are used to actually specify something about the syntax of the program. Rules for identifiers are pretty much the same as in C++. So what are identifiers? Identifiers are names of things like variables, types, and functions. So here are some examples. These are just types. The first two are just, well, actually all of these are types. You're saying you have an int named I. You have a double named underscore I. That's actually okay. It's true in Java, C++, and C. Here is something a little bit more complicated. It's sort of like a class, and we will see structs in a lot more detail later. So this is saying that this is the type, and this is the name. This is the identifier of, this is the variable, which is sort of like a class with two data members. So you can think of it that way, and we'll see the differences between structs and classes later. Okay, so identifiers, what are the rules? They start with the letter or, letter or underscore. So it should be a letter or underscore. Cannot start with a number. Apart from the first position, identifiers can have letters, numbers, or underscores. So you cannot have a number in the very first character of the identifier, but after that you can have numbers. There's usually no limit on the length of a name, but only the first 31 are guaranteed to count. So that's usually you want to rely on this rule. So if you set up two ints where they differ in only the 32nd character, then you're going to have some problems. You're going to have problems if you have names that are 31 characters anyway. So if you have external variables, only the first 6 count in some situations. So you do have to be a little bit careful with the names. Don't make them super long. Identifiers in C are case sensitive, so uppercase X and lowercase x are two different variables. You cannot use a C reserved word or keyword as an identifier, so you cannot say int if. If is lowercase I, lowercase f. That's not allowed because that is a keyword that's used to implement if statements. Okay, unlike C++ and Java, variables have to be declared at the beginning of the block. This is true. Actually, let me just back off this. Typically in C, you want to declare everything at the top, but actually this is fine. This will work. And so this can cause compiler errors in some compilers. Actually, it causes compiler errors if you use the 1988 ANSI standard or older. Anything newer, and almost every system will use something newer. And so I would back off of this and say, okay, this will work. No problems with declaring a variable after an executable statement. So there's a couple of errors. There should be a semicolon here. Sorry about that. So there should be a semicolon here after the 5. And also, on most compilers, this will be fine. It can cause compiler errors in certain older versions of the C compiler.